Okay, so we are doing the homework problems from 4.3, which involve completing the square. I'm doing this on my phone, so I apologize for any slight wobble. I'm going to hold it as steady as I can. The first problem is x squared plus 4x plus 1 equals 0. Anytime you do a problem in which you have to complete the square, you always want to move the constant term to the right. You do not actually want an equation to equal 0 in this case. So we're going to take that positive 1 and we're going to move it to the right, which is going to make it a negative 1. So we've got x squared plus 4x equals negative 1. Now I left a space there. The reason why is we need to put something after that 4x. And this is where the completing the square comes in. So what we do is we take that second term, or the coefficient of the second term I should say, which in this case is a 4. We divide it by 2 and we square the result. So in this case, it happens to end up resulting in a 4. Other problems you work are not going to end up with a 4, most likely, but this one does. So we're going to take that 4 and we're going to add it to both sides of the equation. Okay, so now we've got x squared plus 4x plus 4 equals negative 1 plus 4. Because if you add something to the left, you've got to add it to the right as well. Okay, now we're going to factor the left, which is going to give us an x squared plus 2 equals 3. And because we have double the x squared, or x plus 2, which we can turn that into x plus 2 squared equals 3. So you'll start to see a pattern here. Well, I'm only going to actually do one more problem, but in general, when you're working these, you're going to see a pattern. So we're going to square root the square, which is going to give us x plus 2 squared, take the square root of that, equals plus or minus the square root of 3. We get x plus 2 equals plus or minus square root of 3. We subtract 2 from both sides, which we end up with x equals plus or minus the square root of 3 minus 2, and that's our answer. As far as the number of solutions, there are 2 real solutions. The reason why there are 2 is because you either have a plus square root of 3 minus 2 or a negative square root of 3 minus 2. If there was an I, an imaginary number, then we would end up with solutions that were not real. But in this case, we don't have that. So we have 2 real solutions. All right. Number 4, we have, let's see if I can get this more steady. We have x squared plus 2x plus 8 equals 0. Again, we want to move the constant to the right. So x squared plus 2x equals negative 8. We're going to take the coefficient of that second term, divide it by 2, and then square the result, which 2 divided by 2 is 1, and 1 squared is 1. So that's why we have a 1 there. And we added it to the left, so we have to add it to the right as well. X squared plus 2x plus 1 equals negative 8 plus 1. Factor, and this is what I mean about seeing a pattern. We have x plus 1 and x plus 1. You're basically going to have double everything when you factor it. And on the right, we have negative 8 plus 1 is negative 7. So since we have 2 of the x plus 1s, we can just put them together and just say x plus 1 squared equals negative 7. Okay, square root both sides. Notice we have a negative 7 under the radical, which means we are going to have an imaginary number. Okay, so I'm going to poke the I out and take that negative 7 and turn it into square root of 7 times I. We're going to subtract 1 from both sides. So our final answer is negative 1 plus or minus the square root of 7i. In this case, we're going to have 2 imaginary solutions because we have a plus or a minus, but because we have that I there, which indicates it's an imaginary number, that means we have 2 imaginary solutions, or 2 non-real solutions would probably be the better way to say that. All right, and that's numbers 3 and 4.